All right, so in this video, we're going to be talking about transformations of linear equations. So a family, a little bit of vocab here, a family of functions is a set of functions whose graphs have basic characteristics in common. For example, all linear functions form a family because all of their graphs are the same basic shape. So basically a family of functions, they'll all have something in common. In the case of linear functions, they all make straight lines for graphs. If you look at quadratic functions, that all make parabolas, and so on and so forth. So a family of functions. So today we're going to be talking about linear equations, or a bunch of different kinds of linear equations or linear functions, and they form a family. A parent function is the most basic function in a family. So in each function family, there's one parent. For linear equations, the parent function is f of x equals x. So this is one thing to remember. So remember the term parent function, and remember f of x equals x or y equals x, as I have here. They both form the same graph. So when we're talking about transformations, they're going to be transformed from this one graph. So you can kind of think of this one as kind of a starter function, equation, or graph. And you notice that the graph y equals x, it just makes a straight line diagonally. So it intersects at 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. It crosses at negative 1, negative 1, negative 2, negative 2, negative 3, negative 3, and so on and so forth. So this is the parent function. Y equals x, or f of x equals x. Now, the definition of a transformation is a change in position or size of a figure. So we're talking about that parent function, and it's going to rotate, or it's going to slide up and down, or left and right, and so on and so forth. So there's three different types that we're going to talk about today of transformations. One of them is called a translation, and you can kind of think of it as a slide. So from the original y equals x graph, basically what that does is it goes up and down. So you could see a graph shifting upwards or a graph shifting downwards, something like that. That is a translation. Second one's a rotation. So when you have a graph, y equals x, so maybe it'll rotate this way, it'll kind of spin, or maybe it'll rotate that way, kind of like a little spinner on a board game or something. And reflection, I'll get a little more into reflection towards the end of the video. It's kind of I'm going to kind of break that up in a sort of separate topic than translations and rotations, but you'll see those at the end. All right, so let's take a look at an example of a translation, or kind of like a slide. So what you're going to do is, well, this is just an example. We'll get into some problems that you'll see on your worksheet and stuff. But let's take a look at the graph of both of these. So the y equals x graph, you should just immediately make a diagonal line, just like that. So it goes through 1, 1, 2, 2, 3, 3, all that stuff. The y value equals the x value, so they all have to be equal to each other, the x and the y value with all the points. So 1, 1, 2, 2, 3, 3, so on and so forth. Let's take a look at a graph of y equals x plus 2. So using our slope-intercept shortcut, I have a y-intercept at 2, so let's put a point at 2. I have a slope of 1, so from that y-intercept I need to go up 1 over 1. Okay, and let's make our line. So you notice that, I didn't make that line very straight there. Let me draw it quick. So you notice how, and when I look at the first one, or the starter equation on the bottom, all I do to get that other equation is just move it up 2 spots. So that's where that plus 2 comes from. Okay, so that's a translation. Let's take a look at another example. So we have y equals x, and we have y equals x minus 4. So again, the y equals x. Looks something like that. Let's make a diagonal line right through 0, 0. So that is y equals x. And let's graph y equals x minus 4. So I have a y-intercept of negative 4. I have a slope of 1, so I got to go up 1 over 1. and here is my graph. Now you notice that from my parent to the second one, all I did was shifted the entire graph down 4. So I took that whole linear graph, just shifted it down 4, and that's where that minus 4 came from. Now you might notice a relationship between just the equations, like if I just had a number on the end, like we did in the previous example. If it's positive, shift it up. Negative, it shifts it down that many. And that's pretty much in a nutshell what a translation is. And we're going to take a look at what a rotation now looks like. So once again, I have a couple equations. I have my parent, y equals x, and then I have y equals 2x. So let's graph both of those. Of course, here is my parent function, the y equals x. In blue, and I'll put the other one in green. And here is y equals 2x. So let's use slope-intercept form. So it's like there's a plus 0. So y-intercept of 0. I have a slope of 2, so I need to go up 2 and over 1. So right here. And that is my graph for y equals 2x. Now you notice that all we did here was to get from the starter graph to the second one is I just kind of spun it around. And you can kind of think of a nail or something on the center of that graph. It didn't move at all, but it just spun in that direction. So that's what we mean by a rotation. Another example of a rotation is here. We have the parent function, y equals x. Let's graph that. Just like that. There's y equals x. Let's see, I just did y equals 2x. Let's change this into, what if we had y equals negative 3x? Let's try that out. So I'll put that in red. So a y-intercept of 0. And I got to go down 3 and over 1 for my slope. So 1, 2, 3 over 1. There's my second line, or second dot. Let's make our line. So something like that. So notice in this case, it's spun that way and centered around here. So there we have a rotation. So here we're going to look at some problems that you're going to see on your worksheets. So it asks to graph the following, identify if it is a rotation or a translation. Okay. So we have y equals x and we have y equals negative 5x. So y equals x, of course, is our parent. So we'll graph that on there. That is y equals x. And I'm going to graph the other one. So we have negative 5x. We have a y-intercept of 0. Right there. And we are going to go down 5 over 1 to plot another point. Right there. There is my graph for y equals negative 5x. And if you look at this one, we have to determine if it is a rotation or a translation. So remember, a rotation is like a spin, like a spinner in a game. A translation is kind of like a slide. So this one, it looks like a spin, so this one is a rotation. You can actually look at the equations and determine if it is a rotation or a translation. Notice how in this one, the only difference in the two equations is the slope. This one has a slope of 1, this one has a slope of negative 5. So that causes my parent function to rotate like that. Let's take a look at another one. This one you also have to graph the parent, graph the other equation, and we're going to see if it is a translation or a rotation. So y equals x, just like that. The other one, y equals x plus 3, a y-intercept of 3, and a slope of 1, so we go up 1 over 1. So there is my graph for that one. y equals x plus 3. So is that a rotation or a translation? You notice how going from the parent to the other one, I just slid it up 3. So that is a translation. Now you might notice that the only difference is, just going back to the equations, is that I have no number here and I have a number here. So anytime that is the only difference between the two equations, it is a translation. I'm going to discuss some about the reflections. So what we're first going to do is graph the original equation, find the equation of the reflection, and graph that one as well. So these ones are called reflections. So let's just graph y equals 4x. So we have a y-intercept of 0, slope of 4, so we're going to go up 4 and over 1. There is my graph for y equals 4x. Now to graph its reflection, now a reflection is basically kind of a mirror image across the y-axis. The only thing that we're going to do in the equation is make the number in front of the x the opposite sign. So we notice how this one is a positive 4. Our new equation will be exactly the same, but switch that sign around. So its reflection is y equals negative 4x. So let's graph that one. So again, it has a y-intercept of 0. This one, for a slope of negative 4, I'm going to go down 4 over 1. Just like that. And that's what's called a reflection. So you notice how the only difference between these two is that one has a negative sign and one does not. So that's what's called a reflection. Same thing here. We need to graph the equation for the reflection and graph that one as well. So graphing y equals 3x plus 1, a y-intercept of 1. I got to go up 3 and over 1. So there is my graph there for y equals 3x plus 1. Now the reflection, so we have y equals 3x plus 1. The only difference between equation and its reflection is flip the sign in front of the x. So instead of a positive 3, we're going to have a negative 3. So graphing this one, I again have a y-intercept of 1. I got to go down 3 and over 1. And this will be my graph of y equals negative 3x plus 1. And notice how basically all it did was reflect across that x equals 0 line or that y-axis. So let's take a look at one more. Graphing, finding the reflection, and graphing the reflection as well. So y equals negative 2/3 x plus 2, a y-intercept of 2. I'm going to go down 2 and over 3 for the next point. So that is my graph of y equals negative 2/3 x plus 2. Its reflection, so since it's negative, I'm actually going to make that 2/3 a positive in front of the x. So graphing that one, once again, we start at 2. We're going to go up 2 over 3. And that will be my graph of y equals 2/3 x plus 2.